Hello everyone, welcome to another Quad Education Test Prep Fundamentals video. My name is Tom, and today we're going to be talking about an advanced topic from the SAT and ACT math sections. So this is an advanced topic, not so much because of the mechanics, because the mechanics themselves we'll see aren't that tricky, but rather the concept. So the concept for this can be a little bit of a mind blower if you start thinking about it too much. So that concept is I, the imaginary number. Let's take a look. Okay, so let's talk about I, the imaginary number. So saying that I is imaginary is, well, first of all, a bit of a misnomer because, well, for one, all numbers are technically imaginary because the concept of numbers is man-made itself. And for two, imaginary numbers would suggest that it doesn't really exist. But given all the applications we'll see in a minute, we can certainly see that it does. But setting semantics aside, the reason we call it imaginary is that it's sort of unusual. So we're going to say, what does that mean? It's just sort of unusual and hard to pin down. And by the way, another term you'll hear for this is just complex numbers. So numbers that have I in them are complex. But anyway, this takes us to the point about where it really comes from. So basically, an imaginary complex number, what have you, arises when we find that we have the need to take the square root of a negative value. And so let's look at an example of when that may happen. And for that, we need to look no further than our old pal, the quadratic equation. So I'll write that here really quickly so we can inspect it. It's just x is equal to negative b plus or minus the square root of b squared minus 4ac all over, well, let's say not the x, obviously, because it's on the other side of the equality, all over 2a. And so take a second here to think about this equation and see if you can't figure out when we might end up getting an imaginary number. And yep, pretty clearly here, any instance where the quantity of 4ac is greater than b squared is going to mean that we're going to have a root of a negative, because whenever b squared is less than 4ac, that means this entire quantity in the radical is going to be negative. So let's just take a second here to do a concrete example. So I'll clear my equation out, and we'll just move down just a bit. So what we can do here is demonstrate a pretty routine parabola that has the need for I. So let's just say, let's start with vertex, actually. Let's say y equals x minus 1 squared plus 1. And we know that that's just going to be parabola with the vertex at 1, 1. So it's going to look something like that. And so let's figure out what the solutions to that equation are using the quadratic formula. So really the first thing we need to do is make sure this is in standard form, because the y equals ax squared plus bx plus c form, after all, is what we're going to apply to negative b plus or minus the square root of b squared minus 4ac all over 2a. So if we're going to go from x minus 1 squared plus 1 to this standard form here, we want to factor out the x minus 1. And if you're not comfortable just doing this really quickly, I would say check back with our videos on completing the square and factoring perfect squares, but x minus 1 squared is going to be x squared minus 2x plus 1, and then plus 1 again for what we have outside the parentheses is going to give us x squared minus 2x plus 2. And if we put all that stuff into the equation, what you're going to see is just, so negative 2 for the first value b there is 2 plus or minus the square root of 2 squared minus 4 times a, which is 1, times c, which is also 2, all over 2. And you're going to see right here that this is immediately going to be 4 minus 8. And that's going to equal 2 plus or minus the square root of negative 4 all over 2. And we can just basically simplify that out. The square root of negative 4 is going to be the square root of 4 times the square root of negative 1, which is just going to be 2i. And plus or minus, and then 2, we can simplify that to just 1 plus or minus I as a solution to that. And that lines up with what we're seeing here in the graph, because it never touches the x-axis. So there's not a real solution. Okay, so that's where we can get an I from just regular math that we encounter in our Algebra 2 level. Let's take a look at what happens when we raise I to an exponent, because that's also a very important thing to think about for some of the questions you'll see on these tests. So let's talk about what we've discovered I to be. First of all, I we know to be the square root of negative 1. All right, that's fine. So, just thinking about our exponent rules, anything if you raise it to the first power is, right, itself. And so I to the first power is itself. And now kind of the fun one here, I squared. So what happens when we have I squared is we have effectively, I is equal to the square root of negative 1. If you square a square root, those are, if you want to look at that as a fraction, that's, something to the 2 over 2, which is something to the 1. And like I just said, anything to the first power is itself. So I squared is negative 1. And now for an interesting one, I cubed. So with I cubed, what we have is I times I times I squared, right there, you already know it to be negative 1, and negative 1 times I. Well, anything times negative 1 is, right, negative itself. And so this is probably the hardest one to think about, which is definitely why I keep saying just don't think about this, and that's negative I. So it's the negative square root of negative 1. So get that out of your head, it's negative I. Then for the last one, we have I to the fourth. And so with I to the fourth, what we have is I times I times I times I. And we know what I times I is. We know that I times I is negative 1. And negative 1 squared is just 1. And one thing you may notice here, and this is potentially spoilers for another video, is if we raise I to the fifth now, what we're doing is basically multiplying 1 by I again. So that's just I. And you think, we would have gotten back to the beginning of my series again. So keep that in mind for later. In any event, that's plenty of me talking. Let's take a look at some practice problems now. Okay, take a look at these and see what you can do. All right, let's solve some problems with imaginary numbers. So which of the following is the solution to the parabola with equation y equals x plus 2 squared plus 4? So basically the same thing that I did in my example there, but now with slightly different numbers. So like I did, we're going to make this into standard form. And so x plus 2 squared, that's just going to be x squared plus 4x plus 4, and then plus 4 more. That's going to give us y equals x squared plus 4x plus 8. Then we're going to take that into the quadratic formula, so I'll just sketch it here for reference. Negative b plus or minus square root b squared minus 4ac all over 2a. And we're going to say, okay, negative b, that's negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 8. And so that's all going to be over 2. So then we're going to say negative 4 plus or minus. So 4 squared is 16. And 4 times 8 is 32. And so 16 minus 32 is going to be negative 16. And that's all over 2. And the nice thing about negative 16 is there's a nice available square root in there. So let's just bring this up here and say negative 4 plus or minus the square root of, let's just say 16 times negative 1 to be super thorough to demonstrate what I mean here. And so this guy right here, we can take the square root of negative 16 very nicely. So that's going to be 4. So negative 4 plus or minus 4. And then we have our negative 1 in the square root here, which we know is just going to be I. And all that's going to be over 2. And we just divide everything by 2. Pretty straightforward. We got 4 plus or minus, 2. Because we're going to divide both the values by 2, because that's how division works with a binomial. 2 plus or minus 2i, negative 2, I mean. And we can see here that b is one of those solutions. And breaking from tradition here a little bit for me, I think I made the first one a bit trickier than the second one, but let's go ahead and look at the second one now. So clear that out, and we'll say, all right, what is I to the power of 129? So as I mentioned, this is sort of going through a pattern here. Our pattern for I to the power, I'll just write it again just for the sake of being clear. I to the 1, I to the 2, I to the 3, I to the 4, and then it basically just repeats all over again. So that's I, negative 1, negative I, and then 1. And so you can think about it like I to the 4th, I to the 8th, I to the 12th, I to the 120th. All those are going to be 1 because they're just groups of 4 i's in a row. So I'll go into a more specific way to do this in our patterns video, but for now I'm just going to say it's pretty intuitive to say that, the 120 power for I, that's just going to be 1 because it's just a whole bunch of groups of 4. And then we basically really need to figure out what I to the 9 is. And that's also pretty easy because I to the 8th is also 1. So we just have basically I to the 8th times I, which is I, because anything times 1 is itself. And that leads us to a pretty straightforward answer of A. Okay, that's it for this video. I tried to keep it light on the concepts here and rather focus on the practical side, the mechanics, for solving this kind of question, and I think generally that's a good way to approach complex and imaginary numbers. If you have a bit of free time, it's great to sort of think about what the root of a negative actually is and the implications of it, but generally, and especially on these timed tests, it's better just to do it the right way and keep it moving. Anyway, if you found this material useful, we hope that you will like and share the video and subscribe to Quiet Education. Thank you for watching, and I hope you have a great day.